Hello and welcome back. In this video number 13, we discuss about an equivalent force couple system. Consider a problem. A beam is acted by two forces, 80 Newton acting at point B and 100 Newton acting at point C. The reference coordinate is fixed at one end of the beam, which is at A. The distance AB is 3 meters and distance BC is 3 meters. Question is, replace this force system with an equivalent force and couple moment acting at A. So in order to understand the problem statement, I'm going to use another picture. The beam with a single force R and a couple moment MA acting at A. So the problem statement is, what would be R and MA, which is equivalent to the system shown earlier, like in the figure, which is the 80 Newton acting at B and 100 Newton acting at C. So we know that if we find a single force in place of 80 and 100 Newton, that will be simply the vector sum of these two forces. Since 80 Newton is acting in the minus J direction and 100 Newton is acting in the minus J direction, the resultant of these two forces will be minus 180 J will be the single force acting at A. Now what would be the couple moment MA, which is equivalent to the moment of forces 80 Newton and 100 Newton about A. So we know that the position vector of B is 3I and position vector of C is 6I. So the moment of 80 Newton about A is R cross RB cross minus 80J, since the moment is R cross F. Here R is RB, which is 3I, and 80 Newton is in the minus J direction, it's minus 80J, plus the moment of the second force, which is R cross F again, and in this case the position of C is 6I, so it has to be multiplied. A cross product has to be taken with the minus 100J Newton force, which results in minus 840 K Newton meter. Remember, in each cross product of the vectors, we have to follow the guidelines or steps we discussed in the previous video using the determinant expansion. So the equivalent force system is, you have a minus 180 Newton J acting in the J direction and minus 840 Newton meter in the K direction, is same as the force acting on the beam at two different locations as stated in the problem. Consider another problem. In this case, we have a rectangular block which is acted by four forces, 80 Newton acting at A, 50 Newton acting at point B, 200 Newton acting at C, and 100 Newton acting at D. And the reference coordinate system is placed at O, which coincides with the point of application of 80 Newton A. Replace this force system with an equivalent force and couple moment acting at point A. So as I mentioned in the previous problem, a better representation of this problem statement is you have the rectangular block with the points A, B, and C, D. Now, if we have one single force R acting at A and a couple moment M which is acting at A, what would be R and M which is equivalent to the force system given in the problem? So the R is the resultant of all the forces acting on the block. 80 Newton is acting in the I direction at A. 50 Newton is acting in the minus J direction. Sorry, minus I direction. 200 Newton is acting at C, which is in J direction, and 100 Newton acting at D is also in the positive J direction. So just adding these four vectors, we get 30I plus 300J Newton. So that is the resultant equivalent to all the four forces. Now we know that moment of a force about a given point is R cross F, and since 80 Newton is acting through A, the moment of that force about O will be 0 because the position vector is 0. Similarly, the 50 Newton force is also passing through O, so the moment of 50 Newton about O will be also 0. And 200 Newton, which is acting at Z, is also passing through O, so its position vector will be position vector R will be 0 in that case. So the moment of 200 Newton about O also 0. The only force that create moment is the force 100 Newton acting at D. So the moment of that force is R cross F. So R is RD and force is acting in the J direction, positive J direction. So it's 100J. So we can write M as R cross F. So R cross F is IJK determinant. Then 3 minus 2, 0, because the RD does not have a K component, so it's 0. And the force is in the J direction, so it has 0 in the first column, and then 100, which is the J direction, which is because of the J direction, and 0 in the last column because there is no K component. So we expand this determinant, we can see that the moment is 300 Newton meter. So finally, we can say that the equivalent force couple moment of the given problem is the resultant force 30I plus 300J Newton, which is acting at O or A, and the moment, the couple moment 300 Newton meter acting in the K direction located at the point A.